appreciate you guys volunteering your time to help the students that are coming out to GTC. Really, really excited about the opportunity. We've never really done anything like this before, so being able to impact 200 students and exposing them to what we do here at NVIDIA is a really awesome thing. So who we have up here is Rusty, and he also has his colleague, Allie. They're from Iridescent, and we partnered with them to create the content for this event, which will then live on post-GTC. So I'm going to go ahead and turn it over to Rusty and Allie just so they can give all the information that they can. Go ahead and take it away, Rusty.
All right. Hello, everybody. Just as Christina mentioned, my name's Rusty, and I'm from Iridescent. We have a lot to cover in this 30 minutes, so I'm going to move a little bit quickly. So if you have questions or comments, feel free to chat them. We can try to answer them, but otherwise we can answer questions at a later date. So just a quick introduction. We're from Iridescent, so we develop science and engineering curriculum for students, particularly in underserved, underprivileged communities, to help develop more curiosity, creativity, and persistence. And so the way that we do that is by developing hands-on building activities. So these are open-ended design challenges that are inspired and connected directly to actual scientists and engineers working in the field. So all of our design challenges are mirrored by the engineering design process, where we give them some inspiration. For this event, the inspiration will be NVIDIA. We create a plan, and then we engage in the build, test, redesign cycle. So this is really reflective of that open-ended nature of our design challenges. So you guys are all meeting to learn more about the Techsplorer event with Curiosity Machine. So here is an overview of the day, which I'm not going to dive into. I just want you guys to notice that we will be doing our hands-on design challenge building time from 11 to 12:15. So this is the focus of this meeting today. So just a couple more details. We will have almost 200 middle and high school students doing the design challenges. We have 3 different design challenges that we will be doing. The students will be separated into groups, and the students will create one design challenge during this 1-hour session. So all students will have all of the design challenge building materials provided for them. They'll also have detailed one-pagers that kind of provide the challenge directions and objectives and some of the connections to the concept. So this is important for you guys to reference as well. If you don't understand or are not fully clear on some of the objectives of the design challenge, these will help. And we'll have some extras for you guys as well. So moving on to the design challenge in itself, we have numbered them 1 through 3, and so we'll start off with design challenge 1. I'm gonna turn it over to Allie.
Yeah, so this is our first design challenge that we made inspired by NVIDIA. So this design challenge is inspired by the NVIDIA CUDA and the GPUs that NVIDIA makes. So the prompt for this design challenge is build a machine that can process data using parallel channels. So students will need to work in groups of 2, and they'll need to create a system that can sort objects accurately and efficiently. So in this design challenge, we're making the analogy that the data the students need to process marbles and ping pong balls. And the way the students will process this data is by sorting them. So by separating the marbles from the ping pong balls. So here's one example of a prototype we built. So as Rusty mentioned earlier, all of our design challenges are open-ended, so they can be solved in more than one way. So this is just one prototype we built. But in this prototype, the marbles and the ping pong balls are all mixed up, and they get dropped in from the top. And then these parallel channels, so those are the 4 stacks of bowls that you see, those sort the marbles from the ping pong balls. So the way it works is that the marbles fall through the holes and the ping pong balls stay on top. So I actually have a video showing how it works. Yeah, I can show it one more time. It's short. So that was our prototype that we built. So when the kids are building this, some ways you can help.
Sorry, Allie, can you just make sure that you're talking into the microphone? I think our volume's all the way up here, so if you can be as loud as you can on your end.
Yeah, is this better?
Yeah, you were a little bit better before, so be like right in front of the mic.
Okay. So some ways that you can help the students when they're building this design challenge. So when they're testing, you can help them time how long it takes the marbles and the ping pong balls to get sorted. So we will have stopwatches there, but you can also use your iPhone or your phone or whatever you have. And then another way to help them is to help them assess the accuracy of their machine and help them figure out if it's really sorting well. So in the video, you might have noticed that one of the marbles fell out of the machine and rolled away. So that's one way, that's one example of how it wasn't quite accurate. It didn't really sort everything. So help the students think through how they can test their accuracy. And when they're building and redesigning, so in this design challenge, they have to make at least 2 parallel channels, but you should encourage them to make as many as possible because you can draw the connection to GPUs and how they have millions and millions of parallel channels. You can also, if their test was good and their machine was really accurate, you can encourage them to process an even larger data set, so adding more marbles and more ping pong balls and seeing how quickly they can sort those. And then the last tip I have for you is helping the students build ways to get the data into the machine faster. So in our prototype, I hope you noticed that all the marbles and ping pong balls got dumped in from the top. So helping them build a way that everything can get into the machine really fast and get sorted really fast is another way you can help them build this design.
Okay, great. So I'm going to touch on Design Challenge 2. And so this design challenge was inspired and is connected to NVIDIA's work in the self-driving car field. So we were particularly interested in looking at how the NVIDIA supercomputers are able to process so much information from so many different sensors so quickly. So we used this as inspiration for students to build a system of circuits that's able to navigate around obstacles. So students will be working in groups to build an electronic game board to interpret information provided by sensors. I know that that's a lot to take in, but we'll break it down a little bit. So in the design challenge, the operator, the person operating this game board, the system of circuits, will be connected, will be the supercomputer, I should say in this analogy. So the supercomputer will need to operate all of the switches as quickly as possible. So the cards that they'll be using, that they'll be testing, will act as the obstacles in the way. So the students flipping the cards will be the sensors. So they'll be providing information for the supercomputer to interpret, random information. And so for every red card, the supercomputer must interpret that as an obstacle in front of the vehicle and respond by correctly closing the circuit closest to the car. So the supercomputer needs to operate these switches very quickly in order to not hit any of the obstacles. So we also have a video showing some of my colleagues playing this game as well. So this one is also short as well. Okay, great. And my colleague Judy just heard her voice on camera. So a couple of ways that you can help in this design challenge. So it's really aiding the students in making their circuits. So some students may have never used circuitry or played with these ideas before. So it may be very new to them. So you can definitely help just with the simple, the way of creating the circuit itself. You can also, I really want to encourage students to build multiple types of sensors within their game board. So we're asking that all students or all groups should have different types of switches. And there are a couple reasons for that. One being that we wanted to make the connection that there's all different kinds of sensors aboard a self-driving car. And also it might be a lot it will be a lot of fun to operate switches very differently from one another. So this provides that creative element as well. So for testing, once completed, I want you guys to encourage the students to add more circuits and use more sensors. So if a student is able to complete the task, they've created all their sensors, they've tested it once, and you can definitely increase the speed that the sensors are flipping over the cards, but you can also add other circuits from other groups and other groups to work together to add even more complexity to the design challenge. Okay, great.
Okay, so the third design challenge we have, so this design challenge was inspired by NVIDIA's work in the medicine fields with deep learning. So the prompt for this design challenge is build a network that classifies information. So the students will need to build a network that can send data through different nodes in order to classify something. So because we were inspired by the work NVIDIA does in medicine, the students need to classify things that are cancer and things that are not cancer. So in this design challenge, red beads will represent cancer. So the students need to sort these beads from the other objects. The students will do this by classifying the objects, and they'll send them through a network. So you can see a picture of the network on the right, and at each node, so that's each stack of cups in that picture, there'll be a yes or no question that determines which way the object gets sent.
Great. So in this interpretation of the prompt, you'll see we created this system of networks, or this network that has a system of nodes. And so at each node, there is a question. And so by putting the objects, putting the objects through the system of nodes, you're able to determine the characteristics of what cancer is. So for this, this iteration, we used a red pipe cleaner to mean cancer. And so they're able to run it through the system, and then they're able to look at exactly where the cancer node, or where the nodes responded yes to cancer or not cancer. So you're able to basically strengthen the network by repeating the results over and over. So let's show this short video as well. And so if you'll see, the red pipe cleaner represents cancer in this idea. And so by going through the different nodes, you're able to determine the pathway that leads it to cancer, thus strengthening the network by doing the activity. And so once again, all of our design challenges are intended to be very open-ended, meaning they're able to be interpreted very differently. So this is one way that a student may interpret the prompt, and there's another way as well.
Yeah, so I'll talk about this one quickly. So this is another prototype we built. In this prototype, the blue marbles are cancer, but when we do the event, we're gonna make sure that red beads are cancer. So I'll show you what this one looks like. So this is asking if it's a marble, so yes, marble. I'll just narrate instead. So that the first node, it's getting asked if it's a marble. So the things that are marbles will get sorted out from things that are not marbles. And then next it moves on to the node that asks if it's blue. So things that are blue will get sorted from things that are not blue. So this is just a quick one. The kids will make more complicated ones, but that just sorts out blue marbles from not blue marbles.
Okay, great. So a couple ways that you can help during the testing portion, is try to operate the machine yourself and see if the student's logic is in place. So you can also add more objects, so kind of mix it up. So students will all have the same random objects, but see if you want to add or subtract even more objects and see if the machine, actually works as well, the same way. So you can also help students think about the properties that they are wanting to test for. So we think this is ultimately probably the most important part of this design challenge, is thinking of the questions that they're asking and where they're actually asking those questions. So we think that this will help determine if the design challenge is successful or not. So you can really help the students think through the order of the questions and where to put the questions as well. So excellent. So that is the design challenges is pretty much as they are. So now we wanted to touch on just a couple of mentoring tips, a couple of ideas to keep in mind as we're working with students. So we understand that these design challenges are very different than schoolroom curriculum. And so being that they're open-ended and there's no one right way to interpret the prompt, we want you to help encourage the students, to help improve their designs and rethink their designs through the engineering design process. So you can do this by using your own experiences. You can do this by connecting directly to your work at NVIDIA. So a lot of these concepts may be very high level for the students. So we want to make them as accessible as possible in this short amount of time. We want the students to be able to make the connection to the NVIDIA products through the design challenge itself. And you can do this also by encouraging students to think through the process using open-ended questions. So open-ended questions simply are just questions that don't require a yes or no response, but require more thinking and more thought from the students themselves.
Yeah, and so I know Rusty mentioned this in the beginning, but again, all of our designs, we really focus on getting the students through the engineering design process. So inspiration is NVIDIA, and they'll have sheets in their workbooks to draw their plans. And then helping them with the build, test, redesign process is a really important part of what we do. So when they're testing, helping them test, and then encouraging them to redesign, build again, and test again is really key. So that's another way you can support the students.
Yeah, great. And so with that being said, we really want the students to try and embrace failure. So part of what we do at Iridescent is really encourage students to learn from failure instead of being limited by it. So a lot of students may have never experienced a project like this before, where there's not clear-cut directions, where there's not one right way and various wrong ways, but multiple ways that can be interpreted. So we really want you to help the students deal with their failure in a positive way. So instead of being frustrated and limited by it, we want the students to help learn from those hardships along the way. So a couple of general tips. So this is what we anticipate, some of the hangups will be and where you can help. So I want you to just kind of think about these along the way. So what if a student, what if a student does not want to start building? So how can you encourage the students to think through this part of the design challenge? So maybe they don't necessarily understand the prompt. Maybe they don't necessarily understand where to start. How can you help engage students to be as successful as possible? So also, what if a student gets stuck, gets discouraged by the open-ended nature? How can you motivate them to have a fun experience? So also, maybe a student will finish very early and just, not necessarily want to engage more in the design challenge. So all of our design challenges are meant to have this redesign element. So how can you encourage the student to think differently about the design to make it better? And lastly, another point that we do want to bring up is we are relying on NVIDIA volunteers for some of the content connections as well. So being that you're in the field, you're actually working in the area, You have a bunch of expertise. And so we definitely want you to help make those connections that we're trying to elaborate on with the students. That's great. So we actually ran through that relatively quickly. So I think we definitely have a little bit of time. We have about 9 minutes or so. So we are open if anybody has any questions specifically about the design challenges themselves.
Thanks, Rusty, and Allie for running through that. I did want to mention that you guys are going to be dealing with primarily one challenge. So you're not going to be managing all three. So I hope that kind of gives you guys a sense of relief, because I could tell everybody's like, wow, that's a lot of stuff to go through. So there will be other designs happening at the other tables, but there's going to